Alright, so we're going to do a EOC review on exponential functions. Before I get into the details, I just want to let you know that there are 4 variations of exponential functions that are a combination of positive, negative, and growth and decay. Right? So if a function is positive, it means it's up here. If it's negative, it means it's down here as relative to the x-axis. Right? If it's a growth, right, as x approaches infinity, meaning that as I read left to right for x, my function grows toward positive infinity y, right? And decay, so that's a positive growth and a negative growth, right? This one, negative growth, is going to approach negative infinity. Negative infinity is over here. Positive infinity for y is over there. Okay, so they're all going to approach their respective infinity, positive or negative. And then on the other side, they're approaching an asymptote. In this case, the asymptote is 0. That asymptote is a line that the function gets closer and closer and closer and closer to, but never actually reaches it. Okay, a decay does the opposite. It gets closer and closer and closer and closer to the infinity, or to the asymptote as x approaches infinity, and so does the negative one. Okay, so that is what those look like: a positive growth, a positive decay, a negative growth, and a negative decay. All right, so what dictates what in my function? Right, so my function is y equals, and then the most easiest point to remember is your a, which is right here and right here. If a is negative, it's negative. If b is positive, the whole thing is positive, and that's your y-intercept. Okay, so this is going to be my a value. Okay, if a is positive, it's a positive thing. If a is negative, it's negative. Okay, so that depends. So a is going to tell you, the sign of a is going to tell you on what side of the x-axis it's going to be. All right, and it's also the value of y when x equals 0. Okay, now the other thing is a little bit more complicated. All right, so say I have, this is 0, all right, this is 1, 2, 3, 4, 5, 6. Let's look at the growth so you can understand what it means by the growth. So say that this a value, this equaled 1, right? Say it equaled 1. Yeah, we'll make it equal 1. Now let's make it equal to 100. That way it makes it easier to understand. Let's make it equal to 100. Okay, so if this equaled 100, and let's say that every time it went up by 1x, it increased by 25%. Okay, so 100% in decimal form equals 1. Right? So if I'm going to go from here to here, I have to account for that 100%, and then whatever growth it is. I said it grew 25%, which equals 0.25. All right? So a growth is going to be how much I have to multiply each time is 1 for the previous one's amount, times plus 125%. So that is my b value. My b value is 1 plus 0.25, which equals 1.25. My r value is how much it's changing by. Whether it's a growth or a decay depends on the sign of my r value, right? So if b is greater than 1, that means that r has to be positive, because b equals 1 plus r, plus or minus r. So in order to make b greater than 1 and make the function grow, r has to be positive. In order for b to be a decay, r has to be negative. So r is negative, and b is less than 1. Okay. No, we'll explore this here in a minute. because it's a little less intuitive. All right, this is your rate. R is rate. Okay, so if this was 100, and then 100 times 1 is 100, times plus 0.25 of 100, right? So that's going to be 1.25 times 100 is 125. Now, this is where the growth takes place, right? I don't go 1.25 times 100, I go 1.25 times 125. So it's 1.25, the 100%, plus the additional 25%, right? Times 125. So this one is now going to be 156.25, right? From here it went up only 25. From here to here it went up 31 and 25, right? So now from here to here it's going to go up even more for each progression of x. This was the change in x, the change in y for the change in x from here to here. This was the change in y at x for the change in y to here. These are all the same, right? But the change in y is bigger and bigger and bigger, right? For each change in x. Each time it gets bigger and bigger and bigger, right? That's what makes it grow at an exponential rate. Okay, so let's explore R when it's negative, when this is a decay, right? So if I started at 100 and it's going to decay away at a rate of 25%, that means that each time I progress, it's going to become 75% of its original value, right? Because B equals 1 minus how much it decays by, 0.25 or 25%, 1%, or 100% minus 25% equals 75% or 0.75, right? So each time it does that, from each one on, it's going to be 3/4 or 75% of its previous value, right? So here it's going to be pretty obvious at 75, and then I'm going to take that 0.75 and multiply it by 0.75, and now this is 0.75 times 75, and now this is 56. And then multiply that by 0.75, and now it's 42. Multiply that by 0.75. Now it's 31, right? So the change in x is the same, but the change in y gets smaller and smaller and smaller for each progression, going from left to right or as x approaches infinity. So that is how that works. So my b term, so I have to multiply my b term, whether it's a growth or a decay, times the number of x's, right? So like if I decayed this thing, or if I grew this thing like to 1,000x, right? It would be 1.25 raised to the 1,000. That's a really big number, right? Times 100, even bigger number. It gets huge fast, okay? This is 8 with 98 zeros behind it, okay? If I go smaller, so 100 or 100, 1,000, so if I take 0.75 raised to 1,000, right, that's it's effectively 0. It's so small that the calculator says it's 0, but say it was like 0.99, right? If I take 0.99, that's just 1% off, raised to 1,000, right? Even just taking 1% off each time after 1,000, it's almost 0, right? So it gets closer and closer and closer to this asymptote. The asymptote, by the way, is represented by plus, we'll call it z here, right? That is the asymptote. So if I want to shift everything up, the asymptote shifts up and down. Okay, so I hope that helps you understand everything about exponential growths and decays. Recognize if you want to find your b value, you take this divided by that. So your y value with a greater x divided by your y value from a lesser x, right? That are 1 apart, and that'll find your b value, okay? So hopefully that helps, and we'll get these posted right away.